So, we're dealing with SOH-CAH-TOA. Sine is opposite over cosine's adjacent over hypotenuse, tangent is opposite over adjacent. So in a problem like this, if you're asked to solve for theta here, just for theta, not the whole triangle, the shortest way to do it is to determine with theta which trig function should we be dealing with. And from theta, we know the adjacent leg is 3, we know the hypotenuse is 5. Adjacent and hypotenuse means cosine of theta is 3 over 5. To get theta by itself, I take inverse cosine on each side. Is inverse cosine of 3/5. Left side simplifies to be theta. The right side, making sure your calculator is in degrees rather than radians, put in inverse cosine of 3/5 and round it to the nearest thousandth. What is it? Plug that in, you get 53.13 degrees. So this is why we end up using an inverse trig function. Suffice it to say, if you are searching for a missing angle measure, you're going to use an inverse trig function. If you are not looking for a missing angle measure, you are probably not going to be using an inverse trig function. Angle measures are where you use inverse trig functions. So when you look at this one, you want to solve for theta. This is tangent. Tangent theta is opposite over adjacent. The fact that we knew the opposite length and the adjacent length is what told us to use tangent. So we know theta is going to be inverse tangent of 2/7. So whereas in the previous problem I wrote out all the steps that got us from here to here, you don't have to. You've got tangent theta is 2 over 7, so theta is inverse tangent of 2/7. Rounded to the nearest thousandth, what is that? 15.945 degrees. So again, if you are looking for a missing angle measure, that is where inverse trig functions are going to come up. Here, we are not going to use an inverse trig function. How do you know we're not going to use an inverse trig function? Looking for a side length. So we're looking from this angle, 32 degrees. We know the opposite length. We're looking for the length of the hypotenuse. Opposite hypotenuse, that means sine of 32 is opposite over hypotenuse. How do you solve an equation with a variable in the denominator? You multiply each side by that variable. So we get c times sine of 32 is 3. Then you, to get c by itself, divide everything by sine of 32. So we get c is 3 over the sine of 32, which rounded to the nearest thousandth is 5.661. In this word problem, we have me standing up on a cliff, looking down with an angle of depression of 27 degrees, and I see a parked car. If the cliff is 23 feet high, how far from the base of the cliff is the parked car? I do have to make my adjustment that my eyes are 6 feet off the ground. Because that affects where I'm looking from. Okay? When you have an angle of elevation or angle of depression, the first step is to do what? As these will be word problems, the first step is to read the problem. The second step is to draw the picture. And with angles of elevation and depression, your picture will be a right triangle. I'm going to label this A, B, C. This for base of the cliff, this for the parked car, and this because A generally goes with B and C. What about this right triangle? What measurements do we know? Here, we know that this height here is 29 feet because the cliff is 23 feet high and then my eyes are going to be 6 feet above that. Now, angle of elevation people generally do not mess those pictures up. Angles of elevation are pretty straightforward. Angles of depression, however, people can mess up, because what an angle of depression measures is if I look straight out off the cliff, like this, where these two lines are parallel. The angle of depression measures how far I rotate down this direction. So this is 27 degrees. So what is the measure of angle C? So the measure of angle C is 27 degrees. Reason being, you have parallel lines and you have a transversal over those parallel lines, meaning alternate interior angles will be congruent. We all remember that from geometria.
Yes. Geometry.
They are asking in this question for the length of side A. How far is the car from the base of the cliff? To get that, we are going to use tangent of 27 is 29 over A. Using similar algebra from before, we're going to get that A is 29 over tangent of 27. And rounded to the nearest thousandth, what is that? We get 56.916 feet. So that's how far the parked car will be from the base of the cliff. So, angles of elevation, right, if this were the angle of elevation from the car to the top of the cliff, that would be 27. Okay, it's very clear where the angle of elevation goes in the triangle. Angles of depression, though, like this, people will generally be tempted to make that 27 degrees this angle A in the triangle. Make sure you understand what an angle of depression is so that you avoid that mistake.